Okay, this is just to review error checking and correction. So in the specification you're asked to describe and explain the use of 3 types of error checking and correction: parity bits, majority voting and check digits. Okay, let's have a look at these. These are all where we add extra bits to whatever we send or whatever we use. So a parity bit, we calculate an extra bit and we add it to the start of the data. Okay, so we calculate that extra bit and we add it to the start. Majority voting is where we repeat each bit several times. Okay, so we repeat each bit several times. And then check digit is where we still calculate that extra bit, but this time we add it to the end of the data. Okay, so that's going on the end, that's going on the start, and this is where we repeat each bit several times. So there are 3 separate ways of doing error checking and correction. Let's just have a look at them. So the parity bits first. With the parity bits there's 2 types. There's even parity and odd parity. And basically what we do is we do this. We count up. Okay, so we're still here. We're counting up the number of 1 bits in the data, and then we add an extra bit, the 0 or the 1, so that the total number is even. Total number of 1 bits is even. Okay, so here we've got 1, 2, 3, 4, 5. So we've got 5 ones. So to make the whole thing even, we need to add another 1. So now if I count these up, I've got 1, 2, 3, 4, 5, 6. So that's even parity. And odd parity is the same, except this time we count them up and we make them odd. So I'll just do that. So we've got 1, 2, 3, 4, 5. So this needs to stay at 0 in order for that parity bit and the whole thing to be odd parity. Okay, so even parity just means there could be an even number of 1s, and odd parity means there could be an odd number of 1s. Now we're going to look at how we receive that data. So the way when we get it back, we just do the opposite. We just set this bit aside for a bit. We'll leave that where it is, number 1, and then we count up again, 1, 2, 3, 4, 5. So there are 5 ones, so the bit that's left, the parity bit, should be a 1 to make the number up to even. So 5 is odd, so we need another 1 to make up to 6, and that would be even. So that would be our check. If that was a 0, then there would be something wrong. Likewise with the odd parity, we're doing the same. Okay, but this time we're counting for odd. So we've got 1, 2, 3, 4, 5. There's 5, so the parity bit should be a 0 because 5 is odd. So if we get a 1, then there's something wrong with the transmission. Okay, that means it's incorrect. So parity bits, we just add 1 at the beginning of the number, and it's either 1, depends whether it's even or odd, and it's a 1 or a 0 depending on that. With majority voting, what we do is we use repetition. So instead of just saying, let's say this is the string we're sending, 0, 1, 1, 1, 0, 1, 1, then we repeat each bit 3 times. So instead of just sending one of it, we send 3 of it. So for the 0 we send 3, for the 1 we send 3, for the 1 we send 3, for the 1 we send 3, for the 0 we send 3 zeros, 1 we send 3, and 1 we send 3. Now the idea is that if there's 1 bit that's changed, then the majority should still be correct. Okay, that's the idea. So when we get it at the other end, if we receive it, what we do, we read each group of 3 bits and we distill that down into the majority. So I've got 3 zeros, so it's 0. I've got 2 1s and a 0 here, so we'll take the majority, which is a 1. Here we've got 2 1s and a 0, take the majority, which is a 1, and so on. And you can see that's what we would get. Now obviously the data could be wrong still, but this is another way of making sure that we get some correction if there are 1 or 2 bits out of place. Okay. The check digit is slightly different in that we put the number at the end, but we perform a calculation. So it's a bit more of a calculation than counting. So we calculate, and this is for a UPC barcode for a product. And the way we do this, we've got an algorithm to follow. So the algorithm for UPC codes, product codes, is to add up the digits in the odd positions. So here that's 0, 6, 0, 2, 1 and 5. If we add those up we get 14, and then we multiply that result by 3, so we get 42, and then we add up the digits in the even positions. So that's 3, 0, 0, 4, 4. We don't use obviously we haven't got the check digit yet. Add them up, we get 14, and then we add up those two results. So we've got 42 and 11, that gets us 53. Now we use a mod calculation to give us a single digit. So we do 53 mod 10, that's what we use. So 53 mod 10 will give us 3. And then if it's not 0, if it's 0 then we just use the 0. But if it's not, then we take it away from 10. So 10 minus 3 is 7. So this check digit here should be 7. So that's how we calculate it. Now obviously when we're receiving, we do the opposite way. So let's say this is my number and I've got a 6. So I'll just set that aside like we did with the others, and we add up the oppositions. We get 14, multiply by 3, you get 42. And then we add up the even ones, we get 11, add the 2 together, we get 53, and then we work it out, 3, and then we do 10 minus 3, and we get 7. Now, 7 is not the same as 6, so there's something wrong with this barcode. Okay, the numbers have been read wrongly, or they've been input wrongly, or it's not a valid product at all. Okay, now it's just to do with that. So this is how we would use a check digit. So we check in that 6, it should be 7, so there's something wrong with the barcode. Okay, and that is what we need for error checking and correction, sorry.